Hey there, Mr. Sutton here with the AB Calculus 3-7 Extra Practice Number 2 solutions on the chain rule. This first problem is a little bit of an oddball problem. We're given y equals x squared plus 1 and u equals 2x minus 1. We want dy over du. So the key on this one is we need to take the derivative of both of these things with respect to x and then put them together. So let's do this first one. Derivative of y with respect to x is going to be 2x. So that's dy over dx. And for this next one, if we take the derivative, we've got du over dx equaling the derivative of 2x minus 1, which is 2. Now the key on here is recognizing that if I go ahead and do dy over dx divided by du over dx, you can actually divide these like regular fractions, in which case these dx's are going to cancel out if we do a little same change flip. And we end up just getting dy over du doing this division. Well, this division, we're really just dividing 2x by 2. So that ends up just simplifying to x, which is answer choice D. On this problem, I'm given the graph of f, and also g is 2x plus 1. H is f of g. We want h prime of 1. So to get this, I need to do h prime of x and then plug 1 into it. So this is going to require the chain rule. I'm going to have derivative of the outer function, f prime of g of x. And then we multiply that by the derivative of the inner function, which is g prime of x. So pretty much just the exact chain rule that you were taught. And we're plugging 1 into all this. So f prime of g of 1 times g prime of 1. Let's deal with g of 1 first, and then we'll deal with the primes. So g of 1, we actually know what the g function does, which is kind of a rarity, but we can plug 1 into this. So this is going to be 2 times 1 plus 1, which is 3. So really we're doing f prime of 3 times g prime of 1. Let's deal with f prime of 3 now. That's the derivative of f, or the slope of f, at x equals 3, so this x-intercept right here. Now the slope of this whole line segment is going to be constant. So if I find the slope between these 2 points here, then I've got the slope right here. I've got the f prime right here. So that's going to be, let's see, y2 minus y1, so negative 2 over 4, or negative 2 minus 4 rather, over the x's, so 4 minus 1. And then this is going to be negative 6 over 3, which gives us a slope of negative 2, which seems about right. We're going down 2 over 1. For the next one, we need to do g prime of 1. Now, g is itself a linear function, so g prime of 1 is just going to equal g prime of x in general. G prime of x is just going to be 2, the derivative here, the slope of this line. So now putting it back together for h prime of 1, this is going to be negative 2 times positive 2, which comes out to negative 4, giving me answer choice A. To find the derivative on this problem, I need to use the chain rule. So my outer function is the third power, something to the third. The inner function is the sine of x function, so we'll need to do both of those. Outer function first. We're going to have 3 times something, so 3 times sine squared. And now we have to multiply by the derivative of the inner function of sine. That derivative is cosine. And this is going to end up matching answer choice E. On this problem, they want to know the slope of the line that is normal to the curve y equals radical 16 minus x at the point 0, 4. So this is a multi-step problem. There's a few things that are going on here. First off, if I want to know the slope of a normal line, I need to first figure out the slope of a tangent line and then do the opposite reciprocal of that. So that means I'm going to need the derivative of this thing at the point 0, 4. Let me start by rewriting this in the form that I can more easily take the derivative of. So I'll write this as 16 minus x quantity to the 1/2, because now I can use my power rule with a little bit of a chain rule built into it. This is going to be 1/2 times something to the negative 1/2. So 1/2 16 minus x to the negative 1/2 times the derivative of the inner function. So this is going to be a negative 1 that we're multiplying by. Now I want to find what this derivative equals at the x value 0. So let me put this in a fractional radical form and plug 0 in. I'm going to have a negative I'm going to have a 1 over 2 radical 16 minus 0. So this, using a little PEMDAS, this is the square root of 16 down here, which is 4. 2 times 4 is 8. So we have negative 1 over 8. This is the slope of a tangent line at the point 0, 4. Now we have to be careful because this is one of the answer choices. But again, they don't want the slope of a tangent line. They want the slope of the normal line. So that means we need the perpendicular slope, which is the opposite reciprocal of this. So we have to change the sign to positive and flip the fraction. That would be positive 8 for our perpendicular slope. So that ends up being answer choice A. For this problem, we're told f of x is x squared minus 4, and g is some differentiable function. We want the derivative of f of g of x. Now, since we don't know what g actually does, your answer choice will probably have a g or a g prime in it, and you see all sorts of possibilities here. We do have a value of x, though. Well, actually, no, we don't even have that. It's f of g of x. So yeah, your answer choice should also have some x's in it. All right, let's just take the derivative of f of g of x and see what happens when we do that. So this is going to require the chain rule. I'm going to have derivative of the outer function, so f prime of g of x. And we know that f is actually x squared minus 4. So let me just rewrite this as g of x squared minus 4. And now let me just take this derivative. So that's going to be 2 times all this stuff to the first power times the derivative of this inner function of g, so times g prime of x. This minus 4 gets differentiated away because that's just 0. So now we just have 2g of x, g prime of x. And does that match an answer choice? Because I don't know where else to go with this. It does. It's D. Nice. To figure out this derivative of this function, we're going to need the product rule. So I've got u prime v plus uv prime. And now for the box and ribbon to help organize this, we have our factor of x squared and our factor of sine of 2x, and their derivatives, which will be 2x. And now this is a little mini chain rule here. So we're going to have cosine of 2x times the derivative of 2x times 2. Multiplying it all out now, this is going to be 2x sine of 2x. So we're using our ribbon to multiply it out. And the answers are going to be more or less kind of simplified. So let me just simplify this as we go. This is going to be a 2, an x squared, and a cosine of 2x that we're adding in here. Now this does not match any of the answer choices, but if you look at some of the answer choices, it looks like 2x got factored out in some of them. So let's factor a 2x out here. If I take a 2x out of this expression, that leaves me with sine of 2x for that first term, and this other term is just going to be x cosine of 2x. And that is going to match answer choice E. You got to be careful here. This is a plus instead of a minus, so answer choice E. On this problem, I've got y equals sine of x cosine of x, and I want the derivative of this thing at x equals pi over 3. Now, you could do this just using purely a product rule, and that's one way to do it that I did in another homework solutions. But if you're doing this in the 7-7 solutions on chain rule, the chain rule way to do this is to recognize that there is a trig identity of sine of 2x equals 2 sine of x cosine of x. So this being the case, that means that 1 sine of x cosine of 2x is equal to half sine of 2x. And if I rewrite the y function like this, I can now just use a pretty quick chain rule on this and plug in pi over 3. So using my chain rule, this is going to be 1/2 times cosine of 2x times the inner derivative of 2. So these just cancel out, and you really just got cosine of 2x that you're plugging pi over 3 into on this. So we've got cosine of 2 pi over 3 then. And that's going to be, let's see here, that's like 120 degrees. This is kind of like having cosine of 60, but in the second quadrant. So this is going to end up being negative 1/2 if you use a little unit circle math here. And that's going to be choice A. For this problem, we need the derivative of this crazy looking function. So any way you slice it, the algebra on this one's going to be a little bit hairy, but the fastest way to get there is by just straight up using the product rule and figuring out where things lie. So I've got u prime v plus uv prime, and then my box and ribbon, we've got x minus 1 for one thing, and I've got x squared plus 2 quantity cubed for the other. First derivative of the x minus 1 here, that's just going to be 1, so that's not so bad. Derivative of this other expression, we need the chain rule. I've got 3 times all of this stuff squared, times the derivative of the inside here, so times 2x. And now at this point, let me multiply everything out. So using my ribbon, I've got 1 times x squared plus 2 quantity cubed, so that's just itself. And then for the other term, going the other way with my ribbon, let me collect some terms here. So I have a 3, I've got a 6x, that's a 2x rather, that multiplies to 6x, and I'm adding all this, so 6x. We've got an x minus 1. We also have an x squared plus 2 squared, and that's it. This clearly does not match any of the answer choices. All the answer choices look like they've been kind of sort of factored with some like terms collected. So I'm just going to start the factoring process right away here because I don't feel like multiplying all of this out and then factoring all over again. So I notice that I have a common factor of x squared plus 2 squared. That's the highest exponent of that. So if I take out an x squared plus 2 squared, what's going to be left for this whole expression? Well, that's going to leave me with an x squared plus 2 to the first power for this first term. And I'm also going to have the 6x and the x minus 1 left over inside. And what do I do at this point? Well, I can combine some like terms inside here. So this is going to be, let's see here, we have a 6x squared and an x squared, that's a 7x squared. And we also have a minus 6x and a 2. And it looks like that's going to match answer choice D. For this problem, we're asked for the limit as h approaches 0 of all this stuff. So the key on this one is recognizing that this is the limit form of a derivative. The original function is whatever this x plus h is getting plugged into, so tan of 3x then. And now we just need to take the derivative of this. So this is going to require a small chain rule. We've got the derivative of tan of something, which is secant squared of the same something, so secant squared of 3x, times the derivative of 3x, which is 3. So that's just 3 secant squared of 3x, which ends up being choice B. In order to find the derivative of this function, I have to use the chain rule. So my outer function here, I've got 2 times something squared, is a little bit crazy, but that's what's going on here. So that's the derivative of that is going to be 4 times something to the first power. So 4 times secant of x to the 7th. Next function in is the secant function itself. Derivative of secant of something is secant of something tan of something. So this is going to be multiplied by secant of x to the 7th times tan of x to the 7th. And if you wanted to, if you didn't have to, if you wanted to simplify, you could make this secant squared of x to the 7th, but why bother if you don't have to? The next function in is the x to the 7th. That derivative is going to be 7x to the 6th, and then this one is done. For this problem, we're trying to find the derivative of x radical 2x minus 3. This requires the product rule, so we've got u prime v plus uv prime, and now let's use our box and ribbon. So we've got an x, and I'm going to rewrite this as 2x minus 3 to the 1/2 power. So derivatives are going to be 1. And this is going to require the chain rule up here. This is going to be 1/2 times all this stuff to the negative 1/2 times the derivative of 2x minus 3, so times 2. Putting it all together using my ribbon, I've got, I'm going to rewrite this now as radical 2x minus 3, because I know I'm going to have to simplify all this. And then we're going to be adding, well, let me simplify things a little bit as we go. The 1/2 and the 2 are canceling. So I really just have an x over radical 2x minus 3, if I put that in radical fractional form, To add these together, which I need to do because I only have one fraction in the answer choices, I'm going to need a common denominator. That common denominator is going to be the only denominator of radical 2x minus 3. So to get that over here with this first term, I have to multiply this first term by root 2x minus 3 over itself. That gives me just 2x minus 3 with no radical over radical 2x minus 3. Now I can add the numerators together. So this is going to be, let's see here, 3x minus 3 upstairs, radical 2x minus 3 downstairs. Can't simplify that anymore, so that's just going to be answer choice A.